Hi everyone, how are you? Today we're going to do a more difficult exercise. We started with a couple of easy ones, got ourselves warmed up, so now we're gonna up the ante a little bit and we're gonna do absolute value of x minus 1 less than absolute value of x plus 1. So here's a tricky situation, right? We have two absolute values on both sides of the inequality. So what do? Is there a property to solve this? We did the greater than property before and the less than property before. But this one, we're going to solve with no property because there isn't a property to manage two absolute values in an inequality. So we're not going to do that. How are we going to solve it? We're going to do the definition of absolute value. If you have studied the definition of absolute value, this is going to be a little bit trickier for you. If you hadn't, please do so. Remember that my video is a little bit more oriented towards practice than theory. But let's give it a shot still. If you can keep up, it should be pretty much straightforward. So what we're going to do is dissect each of the absolute values, starting with left absolute value of x minus 1. According to the definition, we're going to have x minus 1 if x minus 1 is greater than 0, or x is greater than 1 on the one end, and on the other end, we're going to have the complementary part of the definition, which is minus parenthesis x minus 1 if x minus 1 is less than 0, or solving that, x is less than 1. So here's the definition. This is how we decompose absolute value of x minus 1. And here's where the graphical part that I explained before is going to become handy, because you're able to see the actual representation of the analytical expression in an XY chart. So let's do that really quick. Here's the graphic representation of absolute value of x minus 1. It's two functions that are put together with the bar chart. The positive one is x minus 1. Here we go. And then the negative one is going to be minus x plus 1, and here we go, or minus x minus 1 in parentheses. Here's the graphic of the absolute value. So now we're going to do the second part, the one on the right. So it's absolute value of x plus 1, and the definition of that, remember that we're doing no property, we're doing the definition of absolute value. So the definition of x plus 1 is going to be x plus 1 if x plus 1 is greater than 0, or x is greater than minus 1. And then the second part is minus parenthesis x plus 1 if x plus 1 is less than 0, or x is less than minus 1. And we're going to do the same as above. We're going to do the graphical representation just so you can see the visual part of it. This is why it's so important to practice. And remember, if you haven't seen functions graphically yet, or graphication of easy functions, I'm quite sure that you're going to be doing that. Okay, so here's the x plus 1 absolute value function, x plus 1 for the positive part, and minus parenthesis x plus 1 for the negative. And here we go. Now we have both functions represented analytically and graphically. Okay, this is the definition of absolute value. Okay, so now we're going to try to understand the question like we did before. What is the problem asking us? Okay, what is the question? What is the exercise? What is the problem asking us to find? Okay, and if you recall my previous video of visual representation, well, we have just a comparison of two functions. Okay, and that's what we're going to do right now. We're going to put those two functions in the same axis. Okay, so here we go. Plot a couple of points. We draw absolute value of x minus 1 on blue, and we're going to draw absolute value of x plus 1 on orange. Okay, and this is the issue right here. This is the problem, okay? The problem is asking us, okay, you have absolute value of x minus 1 less than x plus 1. That's the question. So when is 1 less than the other one, okay? When is the blue one, x minus 1 in absolute value, less than the orange one, absolute value of x plus 1? That is the question, okay? And graphically, if you take a look at the XY chart, you will already be able to see, well, here's the answer, okay? I can see the area in which the orange one is above, it's greater than the blue one, okay? But that's what we're doing. We're just comparing these two functions analytically and graphically, okay? So what we're gonna do is simple. To solve the inequation, we're going to pick the plot points that divide the definition of both, -1 and 1, okay? The ones that are on the graphical part, on the analytical, these points right here, okay? -1 correspond to absolute value of x plus 1, and 1 corresponds to absolute value of x minus 1. And we're going to divide that into real line numbers, and we're going to separate intervals. Why? Because we're going to choose which interval belongs to which side. So if I am in the minus infinite, -1 interval, then we're going to choose minus x minus 1 and minus x plus 1. Okay, because those are the functions that belong to the interval. So let's do that for the interval -1 to 1. Which function, which portion of the belongs here? Well, it's obvious for absolute value of x minus 1. Then we're going to have minus parenthesis x minus 1 because x is less than 1. Now for plus 1, we're going to have x plus 1. And now for the other portion, for 1 to infinite, we're going to choose x minus 1 because it's greater than 1. And then for absolute value of x plus 1, we're going to choose x plus 1. And here we have the 3 separate cases. We're going to name them A, B, and C. And we're going to solve all 3 of them independently. Okay? All 3 of them independently. The way we do that is we solve them as an inequation following the operator, the logical operator. In this case, we have less great, so we're going to have 3 solutions and we're going to intersect, okay? If we had a greater than operator, we would union. But in this case, we have a less operator, less great than, so we're going to intersect. So we're going to write case A, case B, and case C, okay? And we're going to solve 3 separate inequalities, okay? Based on the location that we found before, okay? Based on the definition of the problem for absolute value. So, gonna go with case A first. And here we go. We have minus parenthesis x minus 1 less than minus parenthesis x plus 1. That is following the definition that we saw before, okay? Picking the right interval and the right portion of the function that belongs to that area. For case B, which is from -1 to 1, we're going to choose minus parenthesis x minus 1 less than x plus 1. And for case C, we're going to choose x minus 1 less greater than x plus 1. Again, this is according and following the definition of both functions. We choose the portion that corresponds to the right interval. So this right here is going to be really simple. We just solve, get rid of the parentheses, operate. As you can see, the x cancels each other, so we're going to end up with 1 less greater than -1. So I ask you, when does that happen? Never. That's a contradiction. At no point in mathematics is 1 less greater than -1. So the case solution for here is that there is no solution, okay? And we write that down. No solution for case A. There's nothing to fear, nothing to be afraid of. This is perfectly normal. Let's go to case B. We operate, get rid of the parentheses right here, have minus x plus 1 less than x plus 1. Here we go. Just solve, operate here. Just pass the x to the other side, the constants to the other side, and we're going to have, as you can see, ones cancel each other, 0 less than 2x. Okay, the x added up to the right side. Just gonna flip this so that it looks a little bit neater. 2x greater than 0. It's the same thing. I just flipped it over. And dividing by 2, x is greater than 0. This is the solution for case B, the case of the function being in the interval minus 1, 1. So let's gonna do the third one now, case C. So we have x minus 1 less than x plus 1. As you can see, the x cancels each other and we end up with minus 1 less than 1. And this is a constant. This is something that happens for all the real numbers. Okay, so this is a solution that is infinite. This is a true statement. So we have 3 solutions for each one of our 3 cases. Okay, so what do we have to do now? We have to now intersect, because we had a less operator. So the solutions for all 3 cases is going to be the intersection of all 3 cases. Okay? The original exercise was absolute value of x minus 1 less than absolute value of x plus 1. So it means that the solution for this, according to definition, is going to be the intersect of the individual solutions of each one of the cases. Okay, as you can see, first one had no solution, third one had solution in all real numbers, and the third one is the actual solution itself, the case B. So if we intersect that, the general solution is going to be x that belongs to the interval from 0 to infinite. That is the general solution, the intersection of all 3 cases. Okay? Remember, go back to the graphical part and see when is the orange function above the blue function. When is this greater than the blue? See? This area right here from 0. And you can mark it right here from 0 all the way to infinite. It's always the absolute value of x plus 1 on top of absolute value of x minus 1. That is the graphical interpretation of the exercise. And here, the analytical. Thank you, and see you next time.